In this video, we're going to look at everything you need to know for Cambridge AS Level Mathematics 9709, Pure Mathematics 1, Coordinate Geometry. Let's start with the basics. Finding the gradient of a straight line. To find the gradient of a line, you need the coordinates of 2 points. Then we use the formula m is equal to y2 minus y1 over x2 minus x1. Here, m is the gradient. x1 and y1 are the x and y coordinates of 1 point. x2 and y2 are the x and y coordinates of the second point. It does not matter which point you assign as point 1 and point 2. Let's look at an example. Determine the gradient of line AB, A with coordinates negative 5, 3, and B with coordinates negative 7, 4. Let's say that A is our first point and B is our second. So now we can say the gradient of AB is equal to 4 minus 3 over negative 7 minus negative 5 is equal to 1 over negative 2. This is the gradient of AB. Now let's look at parallel lines. If lines are parallel, they have the same gradient. To prove lines are parallel, all you need to do is show that the gradient of each line is the same. If you are given 2 lines are parallel, then you know they both have the same gradient. A tangent has the same gradient as a line or a curve at the point of intersection. Now let's look at perpendicular lines. If 2 lines are perpendicular, the product of their gradients will be negative 1. The only way that this is possible is if the 2 values are negative reciprocal fractions. A reciprocal fraction is a fraction turned upside down. So as an example, if we have 2 over 3, the negative reciprocal will be negative 3 over 2. If we have negative 7 over 8, the negative reciprocal will be positive 8 over 7. This shows us that if m1 and m2 are the gradients of perpendicular lines, then if m1 is equal to a over b, then m2 must be equal to negative b over a. And you can also use this idea to find unknown values. Remember that a tangent is always perpendicular to the normal. Now let's look at the equation of a straight line. The equation of a straight line is always y is equal to mx plus c. To find the equation, you need the gradient at 1 point or 2 points. If you don't have the gradient, you can use 2 points to find it. To find the equation of a straight line, we substitute the gradient into m. Then you substitute the coordinates of the given point into x and y in order to solve for c. So let's look at an example. Find the equation of the straight line with gradient 5 that runs through points 2, 3. Let's start with the equation of the line. Y is equal to mx plus c. Our y coordinate is 3, so we can say 3 is equal to the gradient 5 multiplied by the x coordinate 2 plus c. And we get 3 is equal to 10 plus c. Move 10 to the left and we see that negative 7 is equal to c. So the equation for this straight line, y, is equal to the gradient m, which is 5, x, plus c, which is negative 7. Let's do another one. Find the equation of the straight line running through points A, 1, 4, and B, 3, 10. We need the coordinates of 1 point and the gradients. In this case, we have 2 points. So we can use these 2 points to find the gradient. So we can say m is equal to y2 minus y1 over x2 minus x1. Let's say that point A is our first point and B is our second. So we can say m is equal to 10 minus 4 over 3 minus 1. And we get 6 over 2, which is equal to 3. Now to find the straight line, our equation y is equal to mx plus c. We need the coordinates of one point. It can be either. So in this case, I'm going to use point A. It has a y coordinate of 4, so I say 4 is equal to m is 3 multiplied by the x coordinate 1 plus c. Let's move 3 to the left. 4 minus 3 gives us 1, and this is equal to c. So the equation for this line becomes y is equal to 3x plus 1. Now you may be asked to find the equation of a straight line in the form ay plus bx plus c is equal to 0. In this format, y will have a coefficient and a, b, and c will be integers. This means that you cannot have fractions, but you can find the equation in exactly the same way as you would for y is equal to mx plus c. Once you have it in this format, then you simply multiply out the fraction. As an example, find the equation of the following lines in the form ay plus bx plus c is equal to 0. The line with gradient negative 3 over 8 running through the point negative 2, 1. So let's start with y is equal to mx plus c. We have a y coordinate of 1 is equal to the gradient m, negative 3 over 8, multiplied by the x coordinate, negative 2, plus c. Now we have 1 is equal to positive 6 over 8 plus c. Let's move the fraction to the left. 1 minus 6 over 8 gives us 2 over 8. This is the value for c. Let's leave it as it is for now. So now our equation becomes y is equal to negative 3 over 8x plus c, 2 over 8. In this form, we cannot have any fractions, so we need to multiply every term by 8. And we get 8y is equal to negative 3x plus 2. The question wants us to put the x, y, and c terms all on one side of the equal sign. Now, you can put them on either side, but I like to keep my x term positive. So I'm going to move all of these to the left, and I'm going to get 8y plus 3x minus 2 is equal to 0. Let's do another one. Find the equation of the line between point A, 2, 4, and point B, 5, 3. Let's start by finding m, the gradient of AB. So I'm going to say that m AB is equal to 3 minus 4 over 5 minus 2. And I get negative 1 over 3. This is my gradient. Now I can use this to find c. Let's use the equation for a straight line. Y is equal to mx plus c. We can use either point. I'm going to use A. A has a y coordinate of 4, so I can say 4 is equal to m, negative 1 over 3, multiplied by x, which is 2, plus c. Now I have 4 is equal to negative 2 over 3 plus c. 4 can be written as 12 over 3. So I'm going to say 12 over 3. Let's move my fraction. So I say plus 2 over 3 is equal to c, which means that c is equal to 14 over 3. Now I can write my equation. Y is equal to m negative 1 over 3x plus 14 over 3. Let's multiply out the fractions and we get 3y is equal to negative x plus 14. Let's move x and the constant to the left and I get 3y plus x minus 14 is equal to 0. Next, let's look at finding the midpoint. To find the midpoint, we can use this formula. Here, x1 and y1 are the x and y coordinates of one point. x2 and y2 are the x and y coordinates of the other point. Again, it does not matter which point you assign as point 1 and as point 2. Let's look at an example. Find the coordinates of the midpoint P on the line MN between M11 and N35. Let's say that M is my first point and N is my second. So for the coordinates of P, we have M has an x coordinate of 1, N has a coordinate of 3, so we say 1 plus 3 over 2. And for the y coordinates, 1 plus 5 over 2. 1 plus 3 gives me 4, divided by 2 gives me an x coordinate of 2. 1 plus 5 is 6, divided by 2 gives me a y coordinate of 3. These are the coordinates of point P. Let's do another one. Determine the midpoint T of line segment PQ, where P is negative 5, negative 4, and Q is 0, 6. Let's say that P is point 1 and Q is point 2. So for the midpoint T, open a bracket, P has an x coordinate of negative 5, Q has an x coordinate of 0, so over 2. And for the y coordinates, we have negative 4 plus 6 over 2. Negative 5 plus 0 is negative 5. So the x coordinate of T is negative 5 over 2. For the y coordinate, negative 4 plus 6 gives us 2. Divide by 2 and we're left with 1. These are the coordinates of the midpoint. Now we can move on to finding the distance between 2 points. To find the distance, we can use this formula. x1 and y1 are the x and y coordinates of one point. x2 and y2 are the x and y coordinates of the other. Let's look at an example. Determine the length of AB if A is negative 5, 1 and B is 1, 6. So we can say that AB, let's say that A is our first point and B is our second. You can open a bracket, 6 minus 1, close the bracket squared, plus x coordinates 1 minus negative 5 squared, all under square root. To make this easier, you can put all of this into your calculator. We can say we have a square root, open our first bracket, 6 minus 1, close the bracket squared, plus our second bracket, 5 plus 1, close the bracket squared, is equal to the square root of 61. We can leave this in root form. Let's do another one. Find the length of the line between C21 and D63. So I can say CD is equal to, C is my first point and D is my second. So I can say 3 minus 1 in a bracket squared plus 6 minus 2 in a bracket squared, all under a square root. Take my calculator, square root, open the first bracket, 3 minus 1 squared, plus, open the second bracket, 6 minus 2, close the bracket, squared, is equal to 2 root 5. In this case, I want to leave my answer in decimals. 4,472 and so on. Let's round off to 2 decimal places and we get 4,47. Now I want to look at intersection using the discriminant. The equation for the discriminant is delta is equal to b squared minus 4ac. You do not need to know delta or use it in your exam. We use the discriminant when working with the nature of roots. If delta is equal to 0, the equation has one root. If delta is greater than 0, the equation has more than one root. But if delta is smaller than 0, the equation has no roots. The discriminant only works with quadratic equations in the form ax squared plus bx plus c. The number of roots an equation has is the number of times it touches the x-axis. So let's make some space. I want to draw in my x and y axes. Think about a parabola. You can draw a parabola with a positive a value running through the x-axis at 2 distinct points. So it has 2 roots. So the discriminant delta is greater than 0. But we can also draw a parabola with a negative a value down here that does not touch the x-axis at all. Here there are no roots. It does not touch the axes, which means the discriminant is smaller than 0. We can also draw a parabola with the turning point on the x-axis, where it only touches the axis once. This means that there is only one root and the discriminant is equal to 0. When working with quadratic equations, solving for x, trying to factorize, we always make the equation equal to 0. A quadratic takes on the equation ax squared plus bx plus c, or some variation thereof. We are looking for the places where it touches the x-axis. And if you were to draw a horizontal line along the x-axis, it would have an equation of y is equal to 0. This is why we make the equation equal to 0 when solving. Let's look at an example. Determine the nature of roots for the following equations. F of x is equal to x squared plus 6x plus 5. For the discriminant, we need b squared minus 4ac. A is the coefficient of the square term, so in this case, a is 1. B is the coefficient of x, so b is 6. And c is the constant, so in this case, c is 5. So now I can say b squared, 6 squared, minus 4, multiplied by 1, multiplied by 5. 6 squared is 36. 4 multiplied by 5 gives me 20. 36 minus 20 gives me 16. The discriminant in this case is greater than 0. So we can see that we have more than one real root. Let's do another one. G of x is equal to x squared minus 2x plus 1. In this case, a is 1, b is negative 2, and c is 1. For the discriminant, b squared minus 4ac. b is negative 2, so I have negative 2 squared minus 4 multiplied by 1 multiplied by 1. Negative 2 squared gives me 4, so I get 4 minus 4, which is equal to 0. Here, the discriminant is equal to 0. So we only have one real root. Let's do another one. H of x is equal to x squared minus 3x plus 10. Here, a is 1, b is negative 3, and c is 10. The discriminant, b squared minus 4ac. b is negative 3, so we get negative 3 squared minus 4 multiplied by 1 multiplied by 10. Negative 3 squared is 9, so we get 9 minus 4 multiplied by 10, which is 40, which gives me negative 31. This value is smaller than 0, so in this case, there are no real roots. Now that we have a general idea of the discriminants, let's look at how we work with points of intersection. We use the discriminant to determine the number of times two graphs intersect. We can consider two curves, a curve and a line and a circle, but we cannot consider two straight lines. We have to use at least one quadratic equation. Here, if the discriminant is equal to 0, the two graphs only intersect once. If the discriminant is greater than 0, the two graphs intersect more than once. But if the discriminant is smaller than 0, the two graphs do not intersect at all. Please remember that if you are working with a curve or a circle and its tangent, they will only intersect once unless the question specifies otherwise. When working with two graphs and the discriminant, we make the equations of the graph equal to each other. Then you move all terms to one side of the equation and make it equal to 0. Add like terms and ascertain your A, B, and C values. Then you substitute these values into the equation for the discriminant. This will allow you to determine the number of times that two graphs intersect. Now I'd like to move on to circles. Let's start with the basics. The diameter touches opposite sides of the circle and always runs through the center. The radius runs from the center to the perimeter of a circle. A chord touches 2 points on the perimeter but does not run through the center. The diameter runs through the center. Any line that touches 2 points on the circumference but does not touch the center has to be a chord. If the radius bisects a chord, then these lines are perpendicular. Bisect means to cut in half, so their point of intersection will always be the midpoint of the chord. A tangent only touches the perimeter of a circle at one point. If it touches more than one point, it is not a tangent. The tangent and the radius are perpendicular at the point of intersection. We also know that a tangent and its normal are perpendicular. So both the radius and the normal are perpendicular to the tangent. This means that the normal and the radius have to be parallel to each other. An angle in a semicircle is 90 degrees. In the diagram, we have got diameter HOK, and H and K meet at the circumference at J. This creates a 90-degree angle. So in your exam, if you are ever told that 3 points lie on the circumference of a circle and 2 are perpendicular, this means that the third side of the triangle has to be the diameter. Now let's look at the equation of a circle. Let's start with equations in the form x minus a squared plus y minus b squared is equal to r squared. In this form, AB gives us the coordinates of the center of the circle. R squared is the square of the radius. In this form, to find the radius, we simply square root r squared. But remember that the radius is a length, so r will always be positive. Equations for the circle can also come in the form x squared plus px plus y squared plus qy plus s is equal to 0. In this format, s, the constant, is not the radius, so please be careful of this. To find the coordinates of the center of the circle in this format, we say negative p over 2 for the x coordinate and negative q over 2 for the y coordinate. In other words, for the x coordinate of the center, we take the coefficient of x, divide by 2, and change the sign. For the y coordinate, we take the coefficient of y, divide by 2, and change the sign. This makes it a lot easier to find the coordinates of the center of the circle. Then, to find the radius, we can say negative p over 2 squared plus negative q over 2 squared minus s, which means we subtract the constant. Let's have a look at some examples. Determine the center and the radius of the circle with this equation. Here we have brackets, so straight away, this is our a value and this is our b value. Remember that for the coordinates of the center, you need to change the sign. Here we have 2, so the x coordinate is negative 2. We have y minus 3, so the y coordinate is positive 3. To find the radius, we simply square root 40. So in this case, I can say that r is equal to square root 40. Let's do another one. Convert the equation into the format x squared plus px plus y squared plus qy plus s is equal to 0. All we need to do here are expand the brackets. So for our first bracket, we're going to get x squared minus 2x plus 1. For our second bracket, we're going to get y squared plus 10y plus 25. Let's move 26 to the left. We get minus 26 is equal to 0. Now we can add like terms. We have x squared minus 2x plus y squared plus 10y. 1 plus 25 is 26 minus 26. That leaves us with 0. So now we can make this equation equal to 0. Let's do another one. Determine the center and the radius of the circle with this equation. Let's start with the center. For the x coordinate, we look at the coefficient of x, negative 4. Divide by 2 gives us negative 2. Change the sign and we get positive 2. For the y coordinate, we look at the coefficient of y, which is 2. Divided by 2, we get 1. Change the sign and we get negative 1. These are the coordinates of our center. To find the radius, we need to square these values. So we can say 2 squared plus, open a bracket, negative 1 squared. Then we subtract the constant in the equation, which in this case is negative 5. We can say minus negative 5. Now we have 2 squared, which is 4, plus 1 plus 5 is equal to 10. This is the value for r squared. So to find the radius, we simply square root. And now we have the value for r. Let's do one final example. Convert the equation into the format x minus a squared plus y minus b squared is equal to r squared. For our equation, the first thing I want to do is I want to move this 11 to the left. And we have x squared plus 2x plus y squared minus 4y minus 11 is equal to 0. Now let's find the coordinates of the center. For the x-coordinate, we look at the coefficient of x. We have 2. Divided by 2 gives us 1. Change the sign. And the center has an x-coordinate of negative 1. For the y-coordinate, I have a coefficient of negative 4. Divided by 2 gives me negative 2. Change the sign, and I get positive 2. I can use these values to find r squared. So I can say r squared is equal to negative 1 squared plus the y-coordinate, 2 squared, minus the constant in the equation, which is 11. So I can say minus negative 11. Now I have 1 plus 4 plus 11 is equal to 16. This is the value of r squared. Now that I have this value and the coordinates of my center, I can fill the values into this format. A is negative 1, so I can say x minus negative 1, close the bracket, squared, plus, open a bracket, y minus b, which is 2, close the bracket, squared, is equal to r squared, which is 16.